All right, we're going to be looking at Unit 4, Lesson 1, talking about degrees and radians. So, really, like, kind of the difference is this symbol is the degree symbol. And so, again, when you see that little circle, and if it doesn't have anything like that, so again, we would say that this would be pi over 4 radians. This symbol right here, the circle with the loop on it, is called theta. And again, we use that for different degree measures, for showing what an angle is. Another example of a radian would be like if it was 2. If theta equaled 2, we would say it's 2 radians. So what is a radian, right? That's probably what we're wondering. So if I look at a circle and I take from the center of my circle to the edge of my circle, I'm going to call that the radius. And so that's going to be a specific distance. And when I take that distance and I run it around the outside of my circle, that's called the arc length. So I'm going to go 1 radius around my circle. And then this angle that's created inside of here, this is what is called 1 radian. So if I take my radius, and again, I also have, because this is the same definition. So my radius is surrounding this circle. I have the radius creating the angle and the radius on the arc, which is what 1 radian is. This angle right in here. So how can we use that, or how does that kind of work? Well, again, theta can be described as the arc length, which we call S. So again, in our equation, S means arc length, and the R is the radius. So in this example, if my arc length is 12 and my radius is 6, I'm going to go ahead and say, all right, well, 12 centimeters divided by 6 centimeters, that's going to give me an answer of 2 radians. So theta equals 2 radians. All right, another example, again, setting it up. S, which is my arc length. So again, traveling this way around my circle is 16, and my radius is 4 inches. So again, if I set it up, I'm going to say, all right, 16 inches over 4 inches. That's going to give me an answer of 4 radians. 360 degrees. So one path, 360 degrees is all the way around my circle. We just call that, the equivalent is 2 pi radians. So 2 pi radians is all the way around the circle, 360 degrees. So similarly, if I divide that by 2, okay, if I divide it by 2, then I get 1 pi radian is equal to 180 degrees. So 1 pi radian is 180 degrees. And so we can create an equivalency, and we can say, again, 1 pi radian is over 180 degrees. That's a true statement. I can also write it the other way, where again, I have 100 degrees on top and pi on the bottom, and you'll see when that comes into play. So let's say I want to convert 60 degrees into radians. So I'm going to go ahead and set up a proportion, and I'm going to say, all right, I have degrees on top, which means I need to multiply with degrees on the bottom so that it cancels out. Well, I see that 180 degrees can be written as pi over 180. So again, as it starts to cancel out, my degrees cancel out, which is nice. 60 pi over 180. For sure, I know these zeros are going to cancel out. I really have 6 over 18 pi. And then again, that can be simplified, divided by 6 to be 1 over 3 pi, or we call that pi over 3. So this answer would be pi over 3 radians. What about if I wanted to find out what is negative 30 degrees in radians? Again, when we rotate, if you look at the blue example, I am traveling this way. This is a positive rotation, a positive path, whereas negative, I'm going the other direction. So because it's negative 30, if I were to kind of draw it out, I would say, all right, You know, 0's right here, 90's down here, 30 would be about right here, potentially. So I'm looking for this angle inside there. Set up my equation. I'm going to say negative 30 degrees over 1. Again, put degrees on the bottom, put pi radians on the top. So I really have negative 3 pi over 18. Negative 3 pi over 18. And if I divide by 3, that's going to give me negative pi over 6. So my final answer is negative pi over 6 radians. One more example for radians, and then we're going to try moving to degrees. Very similar. Again, if I'm thinking, all right, halfway around the circle is 180. This is more than halfway because it's 225. So I know that my answer is probably going to be more than 1 pi radians. I'm going to say 180 over pi, 225 over 180. This one maybe not quite as, as simple. You can use a calculator, or I'm going to say, I bet you if I did 45 times 5, that would be the same thing as down here. So that gets me 225. Again, these are going to cancel out. So I'm left with 5 pi over 4 radians. Again, more than 1. When I when I change it from radians to degrees, very similar process, but I have to put my degrees on top this time because I'm trying to cancel out my pi, my radians. So here I have 2 times 180, that's 360 over 3. So again, we could simplify that to be 120 degrees. 11 pi over 6 radians. Set up my proportion. Again, I got to put degrees on the top so that radians on the bottom cancel out. 11 times 180 over 6. I'm going to start by simplifying 180 divided by 6. That's going to give me 30. And then I know that 11 times 30 is 330 degrees. Last one, again, we can go in the negative direction. That is absolutely okay. So again, if I was to draw it out, that would be like rotating something like this. I'm going to say negative 3 pi over 2 multiplied by 180 over pi. These cancel out. Negative 3 times 180 is negative 540 over 2. And then when you divide that by 2, you get negative 270 degrees. And we're going to talk about another way that we could potentially get this. And again, we're going to look at some common angles. So one of the first ones, or again, one of the very first ones we talked about was 360 degrees equals 2 pi. So if I were to go all the way around from where I started to where I ended, that would be 360 degrees. Or it's 0. Maybe I never left. If I go just 1/4 of the way, again, a 90-degree angle, because 2 pi is the same thing as 360, if I cut that in half, again, pi over 2, pi, 3 pi over 2, 2 pi. So, and we also talked about how 180 degrees is pi radians. So again, very common to split it up into fourths, into quarters like this: 90, 180, 270, and 360. We can also look at, again, 45-degree angles. So if I'm doing it like this, I'm saying, all right, I've got pi over 4. Then I call this one's like 2 pi over 4. Then I've got 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And we can fill in our degree measures as well by adding 90 degrees. So this would be 135, 225, and 315. If I wanted to look at moving it at 60 degrees, okay, and then if that didn't make, when I was counting, just wanted, again, this is 1 pi over 4. This would be 2 pi over 4, but we simplify it to this, 3 pi over 4. This would be 4 pi over 4, but we simplify it to this, 5 pi over 4, 6 pi over 4. Again, we simplify it to 3 over 2. 8 pi over 4, we simplify it to 2 pi. Wanted to make that clear. For 60 degrees, again, that's kind of another common one. So we can think about, all right, I'm splitting this up. I've got 60 pi over 3. I also have 120 degrees, and that would be 2 pi over 3. 3 pi over 3. This next one would be 240 degrees, which is like 4 pi over 3. Again, this one is 3 pi over 3. We simplify 4 pi over 3. And then my final one right here is 5 pi over 3. Let's add in our degrees. Again, 180. This would be 4 pi over 3 is 240 degrees, and 5 pi over 3 is 300 degrees. 6 pi over 3 would give us 2 pi. We're back to where we started. And sort of the last one that is kind of pretty common that I want to talk about again is pi over 6, which we would also describe as 30 degrees. Okay, if I look over here, again, I'm very close to 1/2 rotation. It's 5 pi over 6. This one's a little bit too much. So again, 6 pi over 6. Again, the 6's cancel out. This would be 7 pi over 6. And then again, moving forward, 8, 9, 10. And then I'm almost all the way around from where I started. This would be 11 pi over 6. I'm almost to 2 pi over 6. Which again, 12 pi over 6, which would simplify to 2 pi. Let's add some degree measures. So 30 degrees, we know. 150 degrees right here. Just over half is 210 degrees. And just before a full rotation is 330 degrees. So just some very common angles that you're definitely going to see throughout your work here.